We're back. Let's pick up where we left off here on commutative property of addition and multiplication. So we'll start out with addition. What this means is if I were adding two things. So let me just make up two random numbers. Let me make p equal to 12 and make that little r equal to 5. And if I was trying to add p and r, so add 12 and 5 together, all this means that you're going to get the same thing if you pick it up and you move it over to another spot. So I can do 5 plus 12 instead of 12 plus 5, and I should get the same thing. Yes, 12 plus 5 is 17, and 5 plus 12 is also 17. So it works out just fine. And the way to remember this one is like commutative is like commuting, like driving. So I could literally pick something up and drive it over to a different spot, like at the beginning, add it at the beginning instead of the end, and it still works. All right, multiplication. That one is the same idea. So let me make p and r the same thing for this problem and just do, instead of 12 times 5, if I switch the order and I wrote 5 times 12 instead, and I literally picked up this 5 and moved it to the front and multiplied that first, I'm going to get the same thing, which is going to be 60 equal to 60 for that line. Okay, let me get in the habit of writing things under each other. We have to get in that habit. I saw a lot of you guys take good notes for the PEMDAS, but then you guys were not writing things in the line format. You have to get used to that for your partial credit, for working your way up to Algebra 1. All right, next we have associative property of addition and multiplication. Okay, let's assign values. Let's say that p is 12 again. Let's make r equal to 5 again, and we got one more letter this time, s, so let's make s equal to 3. Okay, and this property, associative property of addition, means that if I had p, let me just write it next to each other, p plus the r plus the s, oopsies, and if I wanted to think about doing the 12 plus the 5 first and then add the 3 last, I'm supposed to get the same answer as if I thought about this problem as doing the 5 plus the 3 first and then added the 12 last. It should give me the same thing. Doesn't matter which group of numbers I add first, if everything is addition between the numbers. And so let me just check it. 12 plus 5 is 17 plus 3 more. After I add the 12 and 5 first, I get 20 on this side. Check the other side. If I added the 5 and the 3 first, I get 8. And if I add the 12 last, I also get 20. So it works out. Let me make this teeny tiny. You guys are not going to like this because you can't do it on your paper, but it's because I don't have my Apple Pencil. So I'm sorry. This goes with the addition one. Okay. I'll just leave it there. Okay. And then now I have the same idea for multiplication. So let me see if I can just write it underneath here. If I put a 12 in for the p, and then I have that times the r times the s. If I decide to multiply the first two numbers first, I should get the same thing as if I decide to multiply the last two numbers first and then come back here and multiply by the 12, because everything is being multiplied. It works. Doesn't matter if you decide to add the end numbers first at the beginning. And you guys have realized this when we were in class and we were doing like 3 times 3 times 3 times 3, and some people were saying, oh, I'm going to do this times this and then this times this, and it doesn't matter because you're going to get the same thing if they're all multiplication. You can associate parts of it first, okay, different parts of it, and it should be coming out the same. So 12 times 5 gives you 60, times the 3 more is going to give you 180. So on this side, I get 180. On the other side, if I do the 5 times 3 first, I get 15. But if I multiply that by 12 last, I still get 180. So this works out, which is really nice, okay? All right, the last one is a zero product property. This one is everyone's favorite. If I start out with any number here. Let's call P 12. And I do 12 times the 0. I'm always going to get 0. Okay, and that works. 12 times 0 equals 0. All right, cool. All right, go ahead and take some time to look at these or pause and rewatch parts of it or cover it up and quiz yourself on it, because we have to know the names that go with these rules. You may have been doing it all your life, but now we need to know the names that go with it, okay? So I'm going to have you pause the video, go through this, and try to see if you can use the property on the problem that you're given, and then come back and check. Welcome back. So the first one, commutative property, means that you can pick it up and commute it, move it, drive it somewhere else if it's all addition. So instead of 18 plus q, I can do q plus 18 and get the same answer. Next one, additive inverse property. If you come back up here to the top, come back up here to the top. Oh, I erased it already. Let me just read it from my previous notes for you. Remember that it's the number that when you add to the original number, you're going to get 0 again. So it's the opposite one that's going to make that happen for you. So in here, they're saying, what is a number added to 15 to give me 0? So you know that has to be negative 15. Oops. Differential. 15 plus negative 15 equals 0. And you could have also written that it was negative 15 plus 15, giving you 0 as well. That counts as well. All right, multiplicative identity property. Anything times 1 is just that thing itself. So you're done with that. Commutative property of multiplication. If everything's being multiplied, you can pick it up and move it into a different order. You can do B times A instead of A times B, and you should get the same thing. Additive identity property. If I add anything to 0 or add 0 to anything, I'm just going to get the same thing back. Okay. 2 times A equals 1. I want my multiplicative inverse property, which tells me that if I want a number here that's going to multiply with this to give me 1, I'm going to do the inverse of it. So instead of, or the reciprocal of the 2, instead of 2 over 1, I'm going to flip it and I'm going to get 1/2. That times the 2 should give you 1 back. Okay. Next one, commutative property of addition. If everything's being added, which is it is in this problem, I can move this to this side of the 9 or move the 9 to the front of the 7. I can literally pick it up and put it in a different spot. And 9 plus 7 should give me the same answer as 7 plus 9. All right, multiplicative identity property, 1 times 45. We know that just equals 45. Anything times 1 gives you itself back again. Associative property. So instead of doing the 5 plus the 6 first, if everything's being added, I can choose to do 6 plus 8 first. So if I do 6 plus 8 first, I should get the same thing. Oops, sorry. After I add the 5, as if I did the original problem and do 5 plus 6 first. Okay, next one, additive identity property. Anything plus 0 is just that same thing back. So that thing is H. So I'm going to write H. It's some number. Some number plus 0 is just that number again back. All right, next one, 13 times 6. Commutative property of multiplication says that I can do 6 times 13 and I'm going to get the exact same answer. All right, I'm going to save this one for you to do with your homework because I feel like this needs a lot of practice. So do this and do this stuff for homework and make sure you check back with me. If not in class, then the keys are going to be posted before the quiz for sure. I've already posted the keys for page 1 through 12. So make sure you check anything unchecked there and do them over again until you get it correct.